Hello, everyone, and welcome to this episode of the Engineering Project Management Podcast, a podcast that's dedicated to helping project managers to sharpen their project management skills. I'm going to be your host for today. My name is Matt Douglas, and in this episode of the Engineering Project Management Podcast, I'm going to be speaking with Akshay Swaminathan. Now, he is an AI researcher at Stanford at the moment, and he is currently doing his MD PhD. Now, we're going to be talking today about the intersection of data science, engineering, and customer centricity. But before we jump right in, here's a quick word from our sponsor for this episode, PPI, a Kaplan company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Hey everyone, and welcome to the podcast. It is now time for our PM conversation of the week with Akshay Swaminathan. So, Akshay, how are you doing today?
Doing well, Matt. Thanks for having me on the show.
Good. So, let's get right into it. So, Akshay, can you tell us a little bit about and tell our listeners about yourself and what you do on a daily basis?
Sure. So, I started out actually in the field of global health. I led a nonprofit that worked in Bolivia, and we worked with indigenous communities there, setting up public health infrastructure. And that, experience was when I first started thinking about health at the level of populations, large groups of people. Basically, what I saw was that the places where we worked, these folks didn't have running water. They had limited access to healthcare. Meanwhile, just a half an hour drive away in the city center, folks are enjoying high-speed Wi-Fi and hot showers. And so that got me thinking a lot about population-level determinants of health. And so that was my first entry point into the field of data and data science and statistics, which, are all great tools you can use to understand the health of populations. And so I studied statistics in global health in undergrad at Harvard, and after that went on to work at Flatiron Health, where I used these tools to help inform FDA decision-making for drug approvals for oncology, so to basically improve the outcomes of cancer patients. From there, I went on to lead the data science team at Cerebral, where we were using data to improve the way we deliver mental health care. And the tools that we built ended up touching, the lives of over 700,000 patients all across the United States. And so now I'm still in this field, the intersection of data and medicine. I'm doing my MD PhD at Stanford, and my research focuses on how we can align AI systems to human values in healthcare. And so broadly, my main goal here is to use data to improve the way we deliver healthcare, and that means getting the right treatment to the right patient at the right time.
Awesome. So how do you perceive the collaboration between data science and engineering impacting the incorporation of customer mindsets into data projects?
Yeah, the way technical teams collaborate with the end customer is really critical. And you see this all the time in healthcare. And actually in healthcare, there's this huge gap, which we call the deployment gap. And the situation is that there are thousands of models that people have built, clinical prediction models to say, is this person going to have a heart attack in the next week, right? Is this person going to get readmitted to the hospital in the next month? People have built thousands of such models, but only a tiny, tiny fraction of those models are actually being deployed in production within health systems. And that means only a fraction of them are actually having any impact in the real world. And the reason for that actually has nothing to do with the tech and everything to do with everything surrounding the tech. Stakeholder buy-in, clinician buy-in, right? scoping out a problem that has real business value to the health system, making sure that the end user has the tech infrastructure to support a model and maintain it and monitor it and evaluate it over time, right? These are all things that are actually, in many ways, a separate skill set from actually building the tech. And, without this collaboration, right, between the technical teams and whether it's the PM teams or the business teams or the end user, you're going to end up with a lot of technical solutions that never end up getting deployed, and it's just a lot of wasted effort. And we see that every day in healthcare.
Awesome. So in your experience, what role do engineering practices really play to ensure that data solutions effectively address the needs and the preferences of the customers that you guys are working with?
Yeah. So what are some of these engineering practices that, I've used with success? So there are, of course, the basics, right? So the fundamentals of, let's make a design doc, right? Never start a project without a design doc. I have seen so many, actually just in the last couple of weeks, I ran into another project that was started without a design doc. And basically the team had built out a solution, and I looked at the demo and I was like, wait, why are we approaching it this way? Basically, the solution involved a really sophisticated system of large language models and whatnot. And I said, why do we need large language models? Why can't we do this with just some simple descriptive data, structured data? And then because there was no design doc, there was no impact analysis that was done, right? And so the team wasn't able to answer basic questions like, what is the impact of this project? What is the expected ROI of this project? And so with engineers are often very excited to just get started building, but a really important practice that I think a level 1 engineer, right, the first thing they do is maybe build, but level 10 engineer, first thing they do is making sure that they're building the right thing. And so that having that design doc is such an important basic step. And then the other practice that I would say again that distinguishes maybe the level 1 engineer from the level 10 engineer is communication, right? Asking questions and really acting almost as a PM, acting as almost like putting your consultant hat on, right? And trying to answer the fundamental questions. What are we building? Do we even need to be building something in the first place, right? These fundamental assumptions to really get at the crux of what the customer wants and needs. So the more that we can encourage our engineers to bridge that communication gap and really figure out, okay, they called us in to build this thing, but it looks like they don't actually need that. They need something else, right? Those are often the insights that are most valuable, that are most time saving. So those are the two practices that I would really advocate for.
All right, awesome. So how can engineers ensure that the solutions, the technical solutions that you guys come up with are not only functional, but also really resonate with the customers?
So I'd say two answers to this. The first is involve the customer in as many decision points as possible. Right? They should be involved along every step of the way, because the last thing you want, it's funny, we actually see this a lot in the global health field as well. So you'll have, an organization that comes into, this happens, in India quite often, right? So, a nonprofit will come into a rural village in India. They'll see that, hey, these people don't have any, bathrooms. So they'll come and they'll build, 50 bathrooms, little outhouses. Then they come back a year later and they see that people are using the outhouses as storage sheds, for their, brooms and other equipment and whatnot. And
gotta get it done.
And they're wondering why, but it's because they didn't take the time to understand what the end user really wants and needs. You have to build something that people are asking for, right? And
right.
So along every step of the way of an engineering project, we encounter decision points. And it's really important. A lot of those decision points we might feel are technical decision points, but actually they're not. Actually, they are design, user experience decision points, and functional decision points that will impact how the end user is engaging with the solution. So, don't build bathrooms that end up being sheds. Is my advice. Involve the customer along every step of the discussion.
Right, and I think that's just an important part of stakeholder management. In general, just understanding what it is that you're actually getting into, understanding the project fully. What you were saying actually a couple of points ago was that sometimes there's a huge difference between the level 1 and the level 10 engineer. So let's talk a little bit about the career paths that we typically see within your field. So like, what are like the possible titles that you might see? Like, how does someone step into this world a little bit, like maybe after college or so, to become an engineer 1 or an engineer at the level of 1? And then how do they progress throughout their career in the field in which you're showing expertise in?
Yeah, so my field is really data science. And so the pathways in data science, typically post-undergrad, the common role is, or common path is, data analyst. And really, once you get into this field, as we all know, getting that first job is often the hardest, right? So once you're a data analyst, there are many paths that you can take. So what is a data analyst really? That's the other thing with these titles. A lot of them are umbrella titles, and they're pretty vague. And the job descriptions can be quite diverse. But in general, data analysts, they're primarily working in SQL or some type of query language. They're dealing a lot with databases. They have to be very, facile with pulling data from databases, generating reports. And then from there are, a number of options. You can go the data, you can stick in the data analytics world, actually. So, data analyst, senior data analyst, analytics manager, stuff like that. And there, as you move up the ladder, you're responsible for more and more of the database stack, basically. And, as you go up, maybe you're, as a data analyst, maybe you're responsible for interacting with the data, cleaning the data, generating reports. As you go higher and higher, you're responsible for maintaining the database, setting up, ETL pipelines, setting up, data quality checks, setting up business intelligence tools for non-technical stakeholders to interact with the data, and basically creating a system, that allows the entire organization to benefit from the data. So that's the data analytics path. Of course, you can also transition into the data science path, and there, you're going to be working perhaps more in languages like Python or R. You're using more statistical. Again, the term data scientist is such a vague term, so there are a lot of different flavors of data scientist. But one such flavor is folks who use techniques in computer science, in statistics, in machine learning. It could be more descriptive statistics. It could be causal inference. It could be traditional machine learning. It could be deep learning. You might be training models. You might be building models. So that's sort of the data science path. And so there, the titles again: data scientist, senior data scientist, staff data scientist, and then up from there. There's also the deployment piece of all this, where you might get into titles like data engineering and ML engineering. So data engineering really responsible for the infrastructure around the data science solutions, right? So if a data scientist builds a model, the data engineer might be responsible for deploying, maintaining, and perhaps even monitoring that model, right? So, hosting that model, ensuring that it's deployed in a way that the inference needs are met, and so that's maybe like more ML engineering. And then data engineering in general might also interface a little bit with the analytics folks, right? Like setting up the pipes between the different incoming data streams, whether it's from vendors or internal sources. So those are some titles, and I'll also mention some less typical titles, at least in healthcare. So in healthcare, a really important role is this sort of implementation role, this translational data science role, right? So the folks around, so you've built a model, but now you want to deploy it within a health system, right? So that requires a different skill set. It's almost an implementation science skill set, right? You have to liaise with the clinicians, with the stakeholders. You have to make sure that people are trained on how to interact with the system. You have to make sure that the system is solving, the right problem. So it's maybe a combination between a technical skill set and a non-technical, more soft skills like PM type skill set, but really a critical role. So anyway, that's a brief overview of some of the titles that you might encounter in this space.
Okay, that's awesome. Thank you for sharing that. The reason why I was asking is because, like, obviously your field is a little bit different from what we see and experience here in the AEC field, but pretty much has like the same exact execution where there is a project or there's an idea or a need. You get in contact with a potential PM or whatever the entity is that's actually going to be taking care of delivering and doing that project for you. And that person has to just be a subject matter expert, learn that material, and then regurgitate that. That kind of goes into one of the next points, which may be a little bit repetitive here, what we're asking, but I want to talk about a little bit about how you can actually get that data over to your customers, because that's a little bit unclear for me, or maybe some of the other listeners here. Like, how do you take that feedback? What kind of feedback do you actually receive from your customers? And then how do you translate that? How do you show that? Like, what kind of modeling do you actually do to express those points and those improvements to the whatever technical features or requirements and all of those things? I hope that my question is actually clear in what I'm asking.
Yeah, well, it sounds like you're asking, how do you translate an ask from a customer into a well-scoped technical project?
Exactly.
So that can be really tricky. So I would say a good mental model for this, and this comes from the negotiation literature. You want to be able to express back to the customer whatever they said to you in a way that gets them to say, yes, that is exactly right. Like, wow, you totally get it. Like, that's the response you want to hear, right? And so that's sort of the first step. You have to listen first. You have to be a really good listener. And, the best PMs that I've worked with, and even the best technical folks I've worked with, they're able to hear an ask, process it, understand what the person really wants, and then rephrase it back to them in a way that makes you feel like, wow, you totally got it. That's exactly right. Right. So if you're not able to say that, or if you attempt to rephrase what you've heard and they say, well, yeah, that's kind of it, but there's also this, but that means you haven't totally gotten it yet. Right. So that's the first step. Make sure you're, you have to be a good listener. And then the second piece of this is, and again, this is sort of the difference between, level 1, level 10. Level 1 might take the ask and immediately translate it, right? Level 1 might say, so customer might say, hey, we want to predict, which clients are going to churn in the next, week. So level 1 might take that question and immediately start thinking about the hows, right? How do we build this model? All right, we're going to use, we're going to start out with a, logistic regression, and then we're also going to try a random forest. And then we're going to pull the features from this data source, and then we're going to do blah, blah, blah. So they immediately go to the how, right? How are we going to build this model? The level 10, right, is thinking about the what and the why, right? So why do you want to build a model to predict client churn in 1 week, right? And then maybe the client says, oh, well, we recently, launched this product feature, and, we want to see, how that affects, client churn or something, So then all of a sudden you get more insight, right? So now I hear that response and I think, oh, it sounds like you just launched a new product feature and you want to evaluate its impact on client churn. And then the client says, oh yeah, that's correct. Like that's what we want. And then you say, oh, well, to do that, building a prediction model is probably not the best way to do that. Like maybe we should do an A/B test instead, right? Maybe we should, get a control group that doesn't get that new feature and then compare the churn between them. So if you ask those, why, what questions and really make sure that, you get that, you can actually save a lot of time. And so I think that's also a hugely important part of translating the client ask into, a technical project, is making sure it's actually the right ask and a meaningful ask. So those are some of the, the recommendations I give. Don't get too caught up in the how. The how is often the second or third conversation, right? In my opinion, the initial conversation or conversations should really just be about the why and the what.
All right, and this is the last question that we have on this list here. So what piece of advice would you like to give to engineering project managers specifically that are looking to foster a more customer-centric approach to their data science projects? So what advice would you give them?
So if you already know that you want to foster a more customer-centric approach, then maybe you should think about structuring your team to be a cross-functional team, right? So instead of having an engineering team with one PM, think about building a cross-functional team that includes, 1 to 2 engineers, a PM, a couple of people from the stakeholder team, and that's your working team, right? And maybe you have some data scientists, et cetera. And that's your working team. So that's the team that is showing up to stand up every day. That's the team where you're doing your weekly, deep dive check-ins. That's the team where you're doing your, retros together. You're doing the sprint planning together. But I think that's that's one very effective approach. That's what we did at Flatiron Health. We did that at Cerebral with great success. And so I think just looping them in, via email or setting up periodic calls is not as effective as having them really be embedded within the team itself. So that would be my suggestion there.
Nice. Well, I appreciate you sharing that. All right, everybody, but we're going to take a quick break here. And when we get back, Akshay is actually going to get into the PM Pitfall segment, where he's going to talk about one of the largest PM pitfalls that he sees within our industry as project managers. Stay tuned. All right, now it's time for our PM Pitfall segment of the week with Akshay Swaminathan. So, Akshay, we are currently just going through this PM Pitfall segment just to talk about any negative implications that we have or that we see with being a project manager. So could you talk to us about a pitfall that you have experienced and how you recommend other project managers to avoid those pitfalls throughout their careers?
Yeah, one of the biggest pitfalls that I've seen, and I've seen in my own work, and I see it, again and again in others' work, is building without an end user in mind, right? So not just in mind, but building without collaborating with an end user. So an example I'll share is, a project I worked on where we were tasked to build a prediction model to predict when a client was going to churn. And on the surface, this seems like a very important task, right? Any company is going to be interested in knowing when their clients are going to churn. But the thing about building models is that unless someone is using that model to inform decisions, unless someone is taking actions based on that model's output, it's a totally worthless model. And that was the PM pitfall that we made. We had scoped out this problem. It seemed to be a very impactful problem. We scoped out a solution, but we didn't have a clear end user, right? And we certainly didn't have an end user that was sitting in on our meetings, that was helping us, design, the solution, that was telling us, this is how we're going to use it on a day-to-day basis. We didn't have any of that. And so as a result, we built the model, and it actually was performing decently well. But then when it came time to deploy, there was no one to use it. There was no one to use the predictions of the model. And so that was a huge pitfall. I ended up in, thankfully we were able to later on make use of the model and people actually used it, but that was only, 6 to 10 months later. So in other cases, this can lead to tremendous waste. And so, what I recommend is identify the end user from day one, and actually they should be the ones driving the design of the solution. So they should be sitting in. I'm a big fan of cross-functional teams where the end user is embedded within the technical team, and they're almost acting as like a daily consultant, on the project. And they're, coming to stand-ups, they're coming to those weekly check-ins, they're coming to those retros. So that would be my big, pitfall there.
Akshay, well, I appreciate you sharing that segment with us. That was very good. And I think that just kind of, it's just something that stands the test of time. We already know that with project management specifically, that like having a collaborative team working together towards the solution is just the ultimate goal, right? It helps us to be more effective in all of our projects and all of our deliveries, and saves us time. That way we can actually get things done on time and under budget. So yes, I would absolutely stand with you in stating that, wanting to have the end user integrated into your processes is definitely probably one of the largest components in having a successful project. So we really appreciate you sharing that with us.
Thanks so much. Yeah, great.
All right, awesome. And how can we find out a little bit more about what you do? Do you have a LinkedIn profile or any books that you typically read, or how do we get to where you are in your career right now?
So I recently came out with a book with my co-author, Howard Friedman. It's called Winning with Data Science, where we talk about, it's all about actually how to be a good data science customer. And so the target audience is folks who work with data scientists and with technical teams. But we've also gotten a lot of feedback that people who are data scientists and who are on the technical side have also really enjoyed and found it helpful. And we cover, a number of, strategies and concepts to help make that collaboration between data scientists and their customers more effective. Everything from learning the terminology to asking the right questions. We end each chapter with a list of, 10 to 15 questions that folks can use in their next conversation, and of course, challenging assumptions. So if you want to learn more about that book or myself, you can go to the website winningwithdatascience.com.
Awesome. It was great having you on, Akshay. Thank you.
Thanks so much, Matt.
All right, everyone. I hope that you really enjoyed everything that we shared today from Akshay and all that he's shared with us about machine learning and data science and project management. So please remember that you can find the show notes for this episode at www.engineeringpmpodcast.com. And there you're going to find a summary of all of the key points that we discussed in today's episode, as well as any of the links to the resources, websites, or the books that we mentioned in today's episode as well. So until next time, I wish you all the very, very best in your engineering project management endeavors. Take care.